All right. Let's see. So class. Yes. Okay. All right. So Victor. See, there we go. All right. We're gonna continue this one from yesterday. Uh, we wrote it out, but did not actually do it. So mathematically, I have set it up. I wrote it, and it's going to be a top minus a bottom, and the bottom part is going to be the one in pink. What's up? Quite possibly. I ended up on World Star too many times to actually, keep throwing pencils. So I don't throw pencils or markers anymore. All right, here we go. So integration right here. If I'm looking at this, I'm going to say, hey, when we talked about this yesterday, if I see something like this, what does that tell me I need to do to be able to do the integration? U sub. Very good, U sub.
Is the use of like the opposite of just like you for like derivative?
Yeah. We substitute it a lot for everything. So we do a lot of substitution because sometimes it doesn't work out nice and pretty.
Integration by parts.
And we'll eventually get into that, but not this year. You guys will work on it when you get to BC or Calc 2. So anyway, let's see. So right here, that one's the Y. This was the X. So I'm going to write it on a new page. 4 minus 6. Minus 4 minus 4x. And then that's my first part, and my second part is just going to be from 1 to 4 of the other side. Minus. Nope, I messed that one up yesterday. This one's going to be a plus. From 1 to 4, 4 minus x dx.
Wait, plus?
Yeah, I messed that up yesterday. Because right here, if I minus this, what's going to happen if I minus that? Because I got this area here. That's going to be this.
Yeah.
And then this area over here, I need to include it, right?
Yeah.
And so that's why I have to add this over here, not subtract. So, I don't know. I guess I was trying to rush yesterday.
Oh yeah, you did do it wrong. I realized it yesterday.
Yeah, okay. All right, so let's go ahead and do this one right here. So U sub, we're going to say that my U is 4 minus x, and then du is going to be negative 1 dx, right? Yeah? Okay, good. Yeah. So from that one right there, that's going to turn into integration from 0 to 1 of u to the 1/2 du. But what's missing?
The derivative thing?
Yeah, the negative. Because to substitute my du for my dx, I got to replace, so it's going to be divided by -1. So I'm going to make that into a negative there. All right, so I'm going to do that again, but I'm going to do it for this next one over here. And so that's going to be a minus sign, integration from 0 to 1. So I'm going to go over here, and in this case, I'm going to call my u. U is 4 minus 4x. So du is equal to negative 4 dx divided by negative 4. So this is going to give me a negative, which turns this to a positive 1/4. And that's going to be now u to 1/2 du. And then this one over here is going to be from 1 to 4. And, oh crap, I didn't leave enough space. So that plus sign, 1 to 4, u 1/2 du, which this changes this to a negative here, because it's the same du as this one right here. It's the same function, it's just my bounds change on that last one. All right, so integrate u to the 3 over 2 times 2 over 3 from, and this is a negative.
Would it be bad if we put this in the calculator instead?
Huh?
Would it be bad if we put this in the calculator?
No.
Like the homework? Like,
No.
let's
Okay. So I was talking to Blade yesterday about this. There's times in which that you need to show the work, and there's times that you can just put it in the calculator. Some of yeah, if you put it in the calculator, you can get the answer. But I think this answer is actually not a calculator answer.
That's like very doable. But
Yeah.
The one I had was like I didn't want to like go through.
You can.
Fractions and do all that.
You can. It's not a big deal. We could have just put it all in the calculator from the beginning, after we set up our integration. When we set up our this whole thing at top.
I want to know how to set up the integration. You're all good, basically.
Yeah. Once I set this up, I show my work of what I've done, and then I can plug that in the calculator. So that will work for a free response type question, especially if it's a calculator portion. You show your work to get to there, you get full points, and you get the answer after you plug it in the calculator correctly. And I'll show the calculator here in a minute anyway, too. All right, so negative, and that's from 0 to 1. This is going to be a plus sign, 1/4 u to the, give me a second, 1/4 u 3 over 2 times 2 over 3 times the 1 over 4 from 0 to 1. And this is going to become a minus sign, that is u to the 3 over 2 times 2 over 3 from 1 to 4. And what do I do now? Before I plug it in, what do I do?
You have to either switch the range of
Your bounds.
Or you have to plug in the u's.
Very good, yeah. So put your u back in. -2, parentheses, 4 minus x, 3 over 2 over 3. And that's going to be plus, what's that going to be, 1/6? Yeah. So it's going to be 4 minus 4x to the 3 over 2 over 6 from 0 to 1 minus 4 minus x to the 3 over 2 over 3 from 1 to 4. plug it in. So if I do the top, that's going to be, oh yeah, that one's ugly. So that's going to be 3. 3 to the third power is 27, square root of 27. 9, 3. So it's 3 rad 3 divided by 3, which is negative 2 rad 3. Minus the lower, which is going to be square root of 4, which is 2, which is 8. Negative 16 over 3. That's that first part. Second part is going to be 1, so it's 0. Minus the lower bound, which is 2, 8 over 6. Minus this one, which is going to be 4 minus 4 is 0. And that's going to give me 16 over 3. So minus oh, it's not 16 over 3. It is 1, 3, negative 2 rad 3. There you go. That's 4 over 3.
I got negative 4 records.
For the whole thing?
Yeah.
Okay, I'm looking right here. So this is going to give me,
I did it kind of differently though.
12 over 3, which is 4. Positive.
Because the 2 rad 3 and the negative 2 rad 3 would cancel out.
Oh, wow, I just got only 4. That's crazy. I don't know. Let's see if I had enough coffee yet to actually math. So I'm doing integration from 0 to 1, and it is 4 minus x close caret 1 over 2 dx minus integration from 0 to 1 of 4 parentheses minus 4x close caret 1 over 2 . Next one's going to be a plus. My integration from 1 to 4 parentheses 4 minus x close caret 1 over 2 dx. Holy crap, I was right. I shouldn't be surprised I was right, but yeah, I was like, oh. Yes, I was right. Yes, see? Prove my math worthy. Is that what you got when you plugged it into the calculator?
Yeah.
Yeah, okay. You could have told me that when I was actually checking it. I thought I was going to get it wrong. Like, man, because problems like this don't come out easy. We're like, oh, answer just 4.
So for sure, it is just easy to put in the calculator.
Okay.
Just do it
Right?
in my head right now. Yeah, no,
Okay, yes, thank you, thank you.
According to my calculations,
According to my calculations,
I am. Mr. Avi.
okay.
Big plan.
All right. There we go on that one. We still needed to do the y value one, right? So we know what the area is. Right? This is what we set up for the y values. So let's go ahead and do this one now. So let's go ahead and do this one. So that -1 could go out front, right? Yes? Okay, -1 go out front, so it's a integration of negative, and that's going to be from 0 to 2 of y squared minus 4 dy. And then I'm going to get out the -4 out front, so that's going to become a plus 1 over 4 from 0 to 2 y squared minus 4 dy.
And this, can you also put this in the calculator? You just put y instead of x.
Yeah.
Okay.
I think it might actually do it as a dy.
Yeah, you can do it
Because
yeah, unless you choose either x
just
or
change
y.
it to x and a y.
Yeah.
Did you try it?
Yeah. I think it.
Okay.
Works. Let me check. I like half asleep.
So by changing this to a y and looking at it from the y direction, does this problem look a whole lot easier than what it did from the x? Sometimes you just need to do that. You just need to look at it from a different perspective to make your math a whole lot easier there.
Oh wait, okay. I am putting it as a y. I actually did separate this. Like actually put the y equation to the.
No, just put the x. All right, so let's see. So this is going to give me a negative parentheses y cubed over 3 minus 4y from 0 to 2 plus 1/4 parentheses y squared or y cubed over 3 minus 4y from.
Yeah, it works that way. Y, dy, y.
Yeah. 0 to 2. And from right there, that's going to be 8 over 3. So a negative 8 over 3. And then that is a minus 8. Lower bound, which is going to be 0. Plus 1 over 4 times 8 over 3. And minus 8 and minus 0 hopefully this works out right. So it's a negative 8 over 3. This is going to be a, oh, let me just keep working through there, plus 8 plus, let's see, 4 over 6. 2 over 3. Minus 2. negative 6 over 3. Negative 6 over 3 is negative 2. Plus 6 is 4. Okay, all right. All right. Let's see. We got one more problem to go over. We already did that one right there. This is actually looking at it from the other direction. Okay, find the area A enclosed by the region of the graph y equals ln x, the x-axis, and the line x equals e. Okay, start by a basic sketch. And so I'm bounding it by, there's y equals ln x, the x-axis. So that means it's going to be bounded by that. And x equals e. So that is right about, so here's 2, and here is e. So e to the first is like 2.7. Yeah. Yeah. So it's going to be right there. So just a quick sketch, and this is the area that I'm bounding that I need to find the area of.
So it's going to be from 1 to E.
I almost heard you.
So it's going to be from 1 to E.
1 to e. So integration of from 1 to e, and my function is ln x dx. Now, it was in the notes. I don't remember if it was this one or it's one of the other ones. Integration of ln x. Yes, it was in the notes. It was in the notes. You have to find it. Not these ones.
Is it not 1 over X?
Okay, because yeah, that would be 1 over x, my derivative, which would rewrite as x to negative 1. And when I integrate that, when I take the integration of that, I add 1, so it'd be x to the 0, which doesn't work out because it would, yeah, that doesn't work. But that's the doing that. But that, yeah, the ln is my derivative. All right, you know you guys can look this up, right? You are, and for those few people who actually have a textbook in front of you, there is a stapler somewhere. Oh, Blade's got it. Yeah. You can look these up, right? I like I said, I put it in the notes. If you go to the back of the textbook, it has all these integration rules.
It's x ln x minus x.
So it's x ln x minus x.
I just know it's conditional conversion. I still know how to prove it.
So, did you guys find where that was in? So, I see 2 textbooks out here.
That's by parts, no?
guys go to the back pages,
Great idea.
of the book, and it shows you integration rules. Number 5 says ln x dx. I know, but I also want you guys to see it here because you don't know which notes it's on. You can just scroll to the back of the book too to help you out if you are in a pinch.
Is it done by parts?
Yes, you end up doing it by that. But we get here and we go from 1 to e. Now, top minus bottom, so that's going to be e. Now, what is ln e? 1.
Wait, I thought ln of.
Yeah.
No, ln of
Wait,
1
no.
is 0.
Yeah, ln of e is 1. So that's going to give me times 1 minus e, and then minus my lower bound. Lower bound is going to be ln of 1 is
0.
Yeah. Right here, what do we get right here?
It'd be 1 then. Would that be 0?
That's 0.
And then over there would be -1. So then it would be +1 again.
Positive 1.
All of that just to get 1.
1 is the loneliest number there could ever be. There we go. That's it. Everyone's gonna like, share, and subscribe. Buy shirts from the merch store.
You'll get free shirts at the end of the year.
These shirts are expensive. If I made them myself, then maybe. But no, I'm not making it myself. So I tried doing the iron-on thing with the 3D printer. It didn't work yet.
Wait.
The 3D printer for t-shirts?
Why is
Why?
there a 0?
Why what?
0. What?
What's 0?
The 0 in the parentheses.
This right here?
Yeah.
Okay, so now let's try this. What is ln of 1?
0.
Yeah. ln of 1 is 0. Make sense?
Yeah.
Okay.